Hello, everyone. Thank you so much for the invitation to be here. I'm only going to be speaking for 20 minutes, and these 20 minutes that I've been allocated has really stressed me out and given me a lot of sleepless nights because it is such a gigantic topic. How do you attract and retain engineering talent? Let's be honest, this is a question we've been asking ourselves for decades, if not longer. And in 20 minutes, I'm hoping to give you some of the solutions we've been using in the UK. But let me tell you, in the UK, we haven't cracked this issue. I wouldn't say that we are further ahead or much further behind the Netherlands. It's really a problem. We have a big UK's skills gap, and for a long time we have had many initiatives in the UK designed to attract more women into STEM, more ethnic diversity, underrepresented people, and I would say on the whole, whatever it is that we've been doing, so much time, so much effort, so much money has been poured into this. It's not really working. The needle hasn't really moved. Now, I'm not here to be pessimistic. I'm definitely here to be realistic because I have a personal experience of being in engineering. Thanks to my dad, who's also an engineer, there was no question that I was going to go into engineering and try and follow in his footsteps. I wanted to be just like Dad when I grew up. And so I went into mechanical engineering, fell in love with computational fluid dynamics, and decided to do a PhD in it. And I had so much enthusiasm for almost 8 years while I was at university doing all of my engineering studies. And then when I was in industry, I looked around as a highly qualified engineer, and I could not see anyone like me. And this really was a problem. I didn't realize it was a problem until years later when I had experience, age, a bit more wisdom under my belt. I didn't realize that for many, many years, even though I had all the qualifications in engineering, that I felt like I didn't fit in. And that gave me the passion and the drive to make sure that no one that is underrepresented in engineering would feel how I felt when I was in the industry. And that's why I end up standing in front of you today. Because I'm really concerned about the fact that there is a lot of potential engineering talent out there, whether that's in the Netherlands, in the UK, all around the world, and we're not harnessing that engineering talent. What are we doing wrong? I think that what my father instilled in me was a real wonder and awe about engineering. I always grew up thinking that engineers are problem solvers. That's what we love to do. We want to fix things, we want to maintain things, we want to create solutions. And engineering is really imaginative. It's actually quite artistic, engineering. But many people, I would say the social kind of norm or the public perception of engineering is that we are brain boxes walking around absolute experts in maths and physics. We're almost walking robots coming up with these solutions. Nobody realizes that actually all the engineers I've met and all the engineers I know have a deep care and desire to improve people's lives. There's such a strong sense of humanity in the engineers I know. And this is not something that we are communicating to others. So I ended up going from advanced research in computational fluid dynamics for the built environment to the media. And when I was working in the built environment, it was probably the least sexy sector of the fluid dynamics industry. If you're a fluid dynamicist, you go into aerodynamics of Formula One cars, you're designing aircraft wings, you're maybe working on reusable rockets, things like that. I was looking at how air flows in buildings, and that's not really cool. But I found it fascinating that you could visualize the invisible on a computer screen. I loved how colorful it was, how accurate, and how it was all based on chaos theory. And this is coming from someone that really struggled with mathematics when she was a kid. But suddenly I could use maths to predict the unpredictable. It was incredible to me. So there I had the wonder and the awe of engineering. And did my doctorate, and my research was useful for various different applications, particularly with reusable rockets. But then 20 years later, after graduating, my research suddenly had a rebirth, a renaissance, because COVID struck. And during COVID, everyone wanted to know how they could determine social distancing measures. Suddenly, everyone was simulating the fluid dynamics in buildings, in aircraft cabins, everywhere that we were occupying spaces. And fluid dynamics in buildings became cool. This was nothing to do with me. It was to do with what's on trend and what's in fashion. And by then, I was well into my media career, and I was making documentaries for television, for channels like the BBC, Discovery, Sky, Al Jazeera, lots of different television networks. And I was trying to find ways to communicate fluid dynamics for everybody. Because I don't think engineering should be just for experts or people with technical minds or a penchant for mathematics. I think anyone can be an engineer if all they want to do is solve problems. So I wanted to tell people about engineering on a mass scale, and television at the time was that mass platform. And I was bringing CFD stories to the general public. And I remember I did a story on, at the time during COVID, the fluid dynamics around an orchestra, because during COVID, orchestras couldn't play, audiences couldn't come into auditoriums because of all the social distancing. So we did a fluid dynamics simulation of the fluid dynamics around instruments and orchestral participants, and it's fascinating, the fluid dynamics that comes out of a trombone versus a flute. And as a result, the orchestra was rearranged, the ventilation air change rates were adjusted, and everyone could go back to enjoying classical music. And various stories like that, where they were accessible, and they were personable, and they were relatable. One of the key things that I think we don't do as engineers, and we're all responsible for this in this room and beyond, is to make engineering relatable and personable. We all, as engineers, have a duty to tell people, just like my dad did, about the engineering that we do. Ask yourselves genuinely, are you passionate about the engineering that you do? I'm sure that you are. You've gone all the way. You've stayed in your careers. You are problem solvers. You're making an impact. Please tell people, because that's the only way that we can enthuse younger generations about what it is that we do. Engineering is such a broad term. It's part of the problem of engineering. Nobody really knows what engineers do. The only reason why I know is because I sat at my dad's drawing board looking at his beautiful pens. This is way before CAD. And he had the most gorgeous stencils and this oak and wrought iron drawing board with a big ruler on a pulley. And I just thought, one day I want to be able to draw my ideas down on paper the way my dad did. I never got to, and my CAD skills are terrible. But it was this idea of visualizing solutions and sketching them down and being creative in that way that made me want to become an engineer. You know, not all engineers have engineering titles, but I do think that engineers who are in engineering already, so this is the retention part, they want to grow. No engineer who doesn't grow stays in engineering. So the engineers that we do have, we have to allow them to get certified, to continue with professional development, get further qualifications, learn about AI, learn about quantum technologies, and stay on the pulse. Engineers don't want to use old technology. They want to be on the forefront, the trailing edge of engineering. So we have to allow engineers to prosper and grow by learning about the latest innovations. And that involves systems thinking. Even though the built environment is not the coolest part of engineering, I mean, I think it is, but many people don't think it's very trendy. This year, a report came out called Connect to Change. It was a report that is free to access, and I urge you all to take a look at this document. It took 2 years to write, and it's all about the built environment as an example of changing systems thinking. Because if you think about it, the built environment is a system. It involves water engineers, electrical engineers, telecoms engineers, manufacturing engineers, construction. I mean, just so many different disciplines of engineering is involved in the built environment. And one of the major things that I think is the problem with engineering is that things have become too siloed. The water engineers only talk to the water engineers, the electrical engineers only talk to the electrical engineers. And there's no collaboration and there's no integration. We can't continue like that. Artificial intelligence is integrating everything, and we need to get with the program. We need to connect, we need to collaborate, and we need to form communities. I was recently at an event by Engineers Without Borders, and it was all about systems change. And during one of the breaks, I was talking to someone whose job title at a construction company was Social Values Manager. I said to her, what does a social values manager do? And she was saying that when they have a big construction company project, they make sure that they are considering all the different communities that are affected by that one construction project. So if you're building a school, what about people who are pensioners in the latter years of their life? What about them? How will they be affected by noise? I don't know, playground. What about, community centers for them? It's considering everybody. Everyone is involved, and it's taking a much more holistic approach to engineering and really breaking out of this tendency towards siloing everything. It's all about connection, it's all about humanity, and I'm always really nervous to talk about those kinds of words at engineering conferences, because I feel a bit hippy-dippy, a bit woo-woo, because we're talking about things that are warm and fuzzy, rather than things that are technical and mathematical. But I'm going to do it anyway, because I don't think we're talking about the human side of engineering enough. Not that I support war, but I recently did a talk about women in engineering, and I'm not going to talk too much about it because Saha is going to be expanding on women in engineering, and she's going to do an amazing job. I've seen her slides, they're gorgeous. But what I will say is that when I did this talk about key female figures during World War II, I learned some really important lessons. So during World War II, the men were sent away to fight. And there were many technical jobs that needed to get done. And the only people that were around to do them were the women. A lot of women at that time, and there were 4 specific women that I focused on and their stories. They were upholsterers, secretaries, housewives. They had roles that they were expected to have. And because of necessity, because there was no other way of winning certain battles in the war, they just rolled their sleeves up and got on with it. They didn't necessarily have qualifications, they had never thought about doing engineering themselves, But they just got on with learning the skills they needed to learn to work transmitters, receivers. They were in Bletchley Park decoding German messages. They were winding coils around iron cores at the Marconi factory. They were doing technical jobs that probably would be considered technicianships today, apprenticeships, leading to degree apprenticeships. You know, they would have gone to technical colleges, all these kinds of things, and had such an impact in the war. I mean, the Battle of Britain, for example, there were 3 to 4 Luftwaffe planes against 1 British RAF plane. And the only reason why we won that battle, and it was a miracle, was because of our communication with our pilots, thanks to these women working all the technology for that. And then as soon as the battle was won, World War II was over, these women then went back to their upholstery jobs, their housewiving, their secretary jobs, and all of that engineering talent just disappeared. So what did we do wrong there? First of all, these stories made me realize that people that need to get on with their technical skills and learn what they need to learn, particularly women, are more than capable of doing that. It's all up here whether we want to go into engineering or not. We have to believe that it's worth our while going into these kinds of professions. And when we do choose them, we are more than capable of staying in these professions. And then, once the war was over, what I saw so clearly was that because of societal expectations, they did not stay. They didn't want to be in jobs where they were not welcome, where they were not encouraged, where they were not given a chance to thrive. So they just went back to doing what they knew their role was meant to be. And then the men came back from war, if they were lucky, and carried on with those engineering jobs instead. So we have to support and nurture the people that choose to do engineering, and we have to make engineering attractive in the first place. And so in the last 3 minutes of my talk, I urge all of you to make engineering attractive. You may be part of the majority. You may be part of the minority. It doesn't matter. Just communicate engineering. Talk about what it is that we do, how you're making an impact, how you're changing society, how you're making a positive difference. Now, I wrote a book that came out in 2023 called Engineers Making a Difference, and it follows the personal stories of 46 engineers that have come from a variety of backgrounds, technicianships, apprenticeships, academic routes. It doesn't matter. What they all had was a passion for problem solving and engineering. And actually, the more unconventional their story, the more compelling their story was. So you don't have to fit convention. And I have gone from feeling like a total imposter, with all of my qualifications in engineering, I've gone from feeling like an imposter in the industry to feeling like I can now make a difference through my differences. And so there's no excuse about whether you're represented, underrepresented. You know, an older white male came up to me at an event recently, and he said he really wants to talk about engineering, but he's scared to because he's in the majority. And I said, please don't have that in your mind. We want to hear about your engineering. It's not about what you look like. It's not about all these categories and labels that we give each other. It's simply about the engineering. And so I would say that if there is one way of changing the system as it stands today, one thing that we can do differently, don't worry about all the pigeonholes and the silos that we are trying to squeeze ourselves into. Instead, let's just talk about the engineering, because ultimately it's engineering that is miraculous. The things we've achieved, the things we're capable of doing, you know, the problems we want to solve, it blows me away what engineers are capable of doing, and that's what we need to communicate to our public, to really show our enthusiasm and the difference we are making to society. So go out there, all of you, I invite you, and tell people why you love engineering. Thank you.
Don't you also think we need a Dutch version of her book with 64 Dutch engineers, right? Yeah. So the idea is that the older man who came up to you and said, should I communicate, is that if we have enough people who do look differently, communicate about their passion about engineering, you do get a better image of, hey, I can be an engineer as well, right? So you don't only need that man who is communicating, you need everyone, right?
I think also, you know, I've been to many conferences where it's women in engineering, and it's a sea of women in engineering. And I think to myself, why am I talking to people who have already converted? You know, shouldn't we be actually talking to the majority?
Yeah.
And I've given keynotes where the room is full of people who are not like me. And I have to say that I have really thanked them for supporting what it is I'm trying to say. Because it's not that I'm trying to convert anyone, but when the majority supports what I am trying to convey, I feel held, and I feel like actually my perspective is heard. So this is about unity. You know, we can have differences of opinions. There's nothing wrong with differences of opinions, but where the problem is, where the obstacles lie, is when those differences are not welcomed, you know, when they're not considered. So, you know, let's have conferences full of the majority, and let's all unite.
Yeah. Is there anyone who would like to ask a question? And the question is a short sentence with a question mark. Or maybe likes to hear some advice, if you have an issue within your own organization, an idea you'd like to share. Can be anything. I see you all thinking. Yes, no. Come up to you with the microphone. Please stand up.
Jean, thank you for your wonderful presentation. I was wondering what you can do about what I hear in my surroundings is that in education, very young people are more often said that, especially girls, physics is not for girls, something like that. These kind of remarks I hear a lot, and what can we do about that?
I mean, has anyone heard of that saying, you can't be it if you can't see it? Yeah. And I think we have to have role models, and again, all of us have the potential to be role models. We just have to speak up. And so I think the more we see unusual or unconventional people speaking up about physics, the more we can champion the fact that you don't have to be a certain way to be in physics. I spoke recently at the Royal Institution in London, and they have 200 years of science talks. Their history is rich, full of really great speakers like David Attenborough, Carl Sagan, Michael Faraday, and an electrical engineer. And
Shini Samara.
Well, yeah. And every single one of those speakers, me included, had absolute love and enthusiasm for science and engineering. You know, the way they talk, I mean, if you just, I can really picture or hear David Attenborough's voice. I mean, he's about a century old now. And there's very few people that haven't grown up hearing his voice at least once. And that absolute immersion in his science is what captivates people. And so I think if we can communicate that to girls, it doesn't matter if you're a man, a woman, it doesn't matter. It's captivating that passion that I think is essential. And with engineering, I think, again, it's about silos. I think we're so caught up in the technicality and getting things right and being, doing everything the right way that we lose that warmth, that relatability. And it's the same with physics. I mean, we have someone in the UK called Professor Brian Cox, a big BBC face for physics. And he talks about physics like he lives and breathes it. He also happened to have been in a pop band when he was younger, which again makes him really relatable. Again, make a difference through your differences. Okay, you've been a pop star and a physicist. That's okay. It's okay. I think it's allowing ourselves to be ourselves. For a long time, I tried to hide that I was female, like wearing baggy clothes to work. And, I've seen more and more as time has developed that women are starting to be more comfortable in their own skin about who they are, as well as being engineers. And we need to encourage that. And I will say thank you to many men who mentor women through that, because it really means a lot when you have someone from the majority championing you, because sometimes we can't always speak the loudest, but when we have a mentor like that, it really helps us to find our own voice.
Yeah. So be passionate about engineering, be personable and relatable.
Yeah, and find mentors who just believe in you, regardless of their demographic. Find people that believe in you. Yeah.
Thank you very much. May I have warm hands?
Thank you so much.